So in this video we will be writing a shellcode injector in assembly language. I have already included these libraries, so we can use these Windows functions. And I have defined a data section and normal code section as we have seen in the previous videos. So the thing is same which we do in the higher languages like C, C++ and C#. So first we will use the open process function to get the handle of that process, and then we will allocate some memory, and then we will write our shellcode into that process using this write process memory, and finally we will start the execution by using the create remote thread function. And at last we will be using this close handle to close the open handle. So let's go and first create a shellcode. I have already created this one, so it's a normal reverse shell. You can start reasoning on 1 2 3 4. So this is the shellcode we are going to inject into the process. So let's copy this. And in assembly you cannot create a single large variable, so what we are going to do is we are going to break this into multiple variables. So let's say shellcode, and each one occupies a byte. So let's before that we are going to do some modifications to the shellcode. We need to remove this /x and convert this into h. So /x to h comma, because there should be comma between these elements. So replace all, and we need to also remove this double quotes. Remove this double quotes, and to represent a hexadecimal number, here you can see E5H, so it can be interpreted as a variable. So you need to avoid that, and you can avoid that by putting 0 in front of this E. So there is always a comma before this variable, so the value. So what we can do is we can say comma, and that should be replaced by comma 0. So we are just adding 0 to the right side of this comma, so that this will become a hexadecimal number instead of variable. So if I go and replace this one, and here you can see all of these will be considered as a hexadecimal number instead of a label or variable. So now we are good to go. Copy this one and paste here. So we need to do some modifications. Let's say another variable shellcode to byte. So now copy this and paste here. After pasting, make sure these are unique. You can also give some random numbers. That's not a problem, because all of these will be in continuous manner. These all bytes will be allocated in a continuous manner. So you can just refer to the starting of the shellcode to get the length. And we need to add h at the end of this values. Okay, now we have the shellcode ready. We need to find the length of the shellcode. So that is very simple. Let's say shellcode length, let's say d word, and dollar uses the current cursor position minus this shellcode address. So this shellcode is the base address of the starting of this fch, and we are subtracting from this current cursor position, which gives you the size of this entire shellcode. So you no need to worry about these shellcode 10, 11, 12, etc. You can directly say dollar minus shellcode. So we will be getting the size of this entire shellcode. So dollar minus shellcode and divided by the size of each element of this array, that is byte. So you can say type shellcode. You can also simply say divided by 1, but if you want to change this data size of this value in the future, you no need to change here, because this type will be dynamically retrieved. So we have everything ready. So let's go and write this function. So we need to push these parameters onto the stack from the right to the left. First we need to push this process ID and inherit handle and desired access. So let's push the process ID. So let's say for now process ID and push 0 and push desired access. So that is this process all access. So that means copy this, H or so we are getting process all access. I think you can have this process read information and VM read write. So these two are enough, but just for the sake of tutorial you can use this process all access. So now let's call this open process, and at last we need to call this close handle to close the handle. So we need to, let's create a variable, let's say p handle. So the handle will be the d word, and we are going to copy this function return value, that is the process handle, into this variable we have created. So move p handle comma eax. So the eax contains the return value of this function, and that is the process handle, and it will be moved into this variable. And we need to pass this value into this close handle to close that handle. So let's push p handle and call close handle. So this will close the open handle. So we are just opening and creating handle. Let's go and create some memory region using this virtual alloc x. So as usual we need to pass the parameters from right to left, that is from bottom to top in this view. So the first one is protection type. So we will be using page read write execute, and that value is 40. Push 40. So we can just say open process and close handle, and this one is virtual alloc x. So we are pushing this page read write execute and then mem commit and mem reserve. Push and mem reserve. So now we are good to go. And the next parameter is the size of the region of memory to allocate. So how much we need to allocate, that is the length of this shellcode length. So push this as well. And the next one is base address. If you we don't need to define this, the OS will search for this much length of free memory region and will allocate at that address. So we will get the base address of that empty memory region we have allocated in the function return. And the last one is the first parameter, that is process handle. So push p handle and finally call virtual alloc x, and let's create another variable, that is base address. This is also an integer, and move the return value which will be stored in the EX to the base address. So we have base address of that remote process. Now next thing is we need to write the shellcode into that remote process using write process memory. So the last parameter is number of bytes returned. So if the function succeeds, it will return a value, that is the number of bytes this function has returned into that process. So let's create a variable. This can be optional. Bytes return dword and push offset bytes return, and the size number of bytes to be written, that is the shellcode length, and the pointer to the buffer that contains the data, that is our push offset shellcode. So this will push the base address of the shellcode variable and where we want to write, that is push base address, which we got from virtual alloc x. And this one is process handle. So push p handle and finally call write process memory. So now we have written, and there is one step left, that is to create remote thread, and the last value is thread ID. So this is also a out parameter. So the function will write to that variable. So let's say thread ID, let's initialize this, push offset thread ID, meanwhile let's go and build and see if there are any errors. Oh, there are errors. Okay, push, let's say 112 for now, undefined symbol 0, so we need to put the 0. Let's again build this. Okay, again we need to put H to represent the hexadecimal, and we are good to go. Okay, so we have pushed the thread ID, and after the function has executed, we get the thread ID value into that variable. So creation flags is 0, that means thread runs immediately after creation. push 0 and the pointer to variable that is possible. So this is like a parameter to this function you are executing. Since you are executing the shell code, we don't need to pass any parameter. So this parameter is used for DLL injection to pass the DLL path to this road library. So in our case we don't need that, so we can push 0 and stack size is starting address. So the starting address is base address, and next one is 0, and thread attributes we can pass this 0, and finally push handle to that process. Now call create remote thread. So now our code has been completed. Now let's go and start a 32-bit process because this is a 32-bit program, and let's start the listener. I think I have already started this. 1 2 3 4. So let's run this. Okay, we did not get the shell. Okay, sorry, I did not give this process ID. So let's copy this process ID and put here. So let's build this again. So let's run this, and we can see the shell. So we successfully executed the shellcode injection in the assembly language.